Good morning, guys. Today we are going to discuss about the lab program. Okay, to count the number of ones and zeros in two consecutive memory locations. Already we have completed some of the portions of lab. So today we are going to discuss about count the number of ones and zeros in two consecutive memory locations. Okay, let us see into that. Let us look into that. Okay, so today's the program has been given. Here it is. See, this is the program. Area, already you know that one. Variant is called as ROM area. So this is called as the name of the project, and code that we are going to write the code, and the code whatever it is there, which is called as read only section, because the ROM area which is not possible to read write, it is a read only memory. Okay, so if you are giving data here, it is called as read write memory, which is called as RAM. So you can modify the contents in the data section. In the code section it is not possible. Okay, now here I have declared two variables called as zeros and ones. So what is meant by Rn here? The register number is initialized of R0 to the variable zeros. Repeating once again, Rn is called as register number. So we are initializing the R0 to zeros variable, like that. Rn R1 is a register which is initialized to R1. Okay, so this is 1 is a variable which is initialized to R1. Okay, now let us actually the program will start from here. LDR R2 equal to memory. What is that memory? Memory is a location. Here we have given a variable, the memory. Here two memory bytes are there. So 0x45. What is 0x45? The 45 stands for, the X stands for hexadecimal. What is the value of it? 00045. Actually we have taken, this is a 32-bit value because we are doing in ARM processor. In ARM processor, that is a 32-bit architecture. We are writing for any value in the form of a 32. So what is actual value here? 000 is nothing but 0045. The 45 will be written like this. Okay. Now here initially the address of this memory will be copied into R2. Okay, now what is that LDRH? As of you know very well you know very well about that. What is that? H stands for half word. Okay, ARM processor supports three data formats. One is called as word, half word and byte. Now in that LDRH stands for load the register R3 of half word. So the R2 is pointing to memory. Memory contains 45. So the 45 will be represented like this. Here the lower bytes or lower half word will be stored in the R3 register. Okay, here I have shown here complete thing. The other 2 bytes will be represented as zeros. Whatever it is there, the other 2 bytes will be represented as zeros. Okay, now this is 16-bit. The rest of the 16-bit we are not showing here. Actually the ARM processor, which is 32-bit, this is 4 plus 4 plus 4 plus 4, which is called as 16-bit value. So here the R3 register is storing a 16-bit of the R2 which is pointed to the memory. Okay, now here we are initializing R5 with 1. Why we are initializing, we are moving R5 with 1 is nothing but for every iteration of R5 it is counting the number of ones and zeros. So here this is not for count purpose. For the count purpose we have created two variables called as zeros and ones. The zeros, which is called as R0, will count the number of zeros, how many number of times it will be shifted here, and it will count the number of ones will be given by R1 register value, which is using that ones variable. Here the R5 is initialized to 1. Okay, let us assume that R5 equal to 1. Now we are performing that AND operation. What is that AND operation? R4 equal to R3 and R5. Here I am showing here. So here the first iteration we are showing here, R4 equal to R3 into R5. So here what is the first iteration it is explaining about here? R2 is assigning to address of the memory. What is the memory here? 0x45. So R3 will contains the 16-bit, which is not 32-bit. We are not storing because of half word. Okay, 0045, that will be represented like this. We are initializing R5 equal to 1. That is the first iteration is started here. Now here it will come here. So here and R4 equal to R3 and R5. So what is the resultant value that we will look into here? What is R3 value? 0045. 0045. Now what is R5 value? 1. So it is represented as all zeros. The last significant bit is least significant bit as 1. Now the resultant of AND operation will become 1 here, because if both are 1s then only the resultant will be 1. Otherwise it will be equivalent to 0. So in all the other bits it is represented as zeros except the least significant bits are 1. That's what the resultant of R4 is 1 at the least significant bit position. Okay, that's what the resultant is 0001. Now is R4 is equivalent to 0? Here we are checking the condition. We are comparing the R4 with 0. We are checking where branch if it is not equal. Where we are branching to the INC_1. So here whether the R4 is equivalent to 0 or not. If it is not equivalent to 0, jump. Where it is jumping here, we are incrementing the ones variable by 1. Once it is incrementing the variable by 1, again it is continuing for the next part. What is that? Shift left of R5 by 1 time. How it is shifting? What is the R5 value initially? 1 here. So once it is shifted by left by 1 time, what is the value will become? 2. So what is the value here? R5 equal to 2. Again we are checking is R5 is equivalent or not equivalent to 1001 followed by 4 zeros. Why we are taking? For checking the half word of the memory location. How many number of bits will be there in that half word? 16 bits will be there. For checking of 16 bits we are taking 1 here. Until all these times we will shift left by R5 by 1 time. Every time we will check that one. For that case we are keeping in the this position. These are all these bits. 4 zeros has been given here. Once it is given that 16th bit. So 0 to 15th bit it will be zeros, it will be there. In the 16th bit position if it is 1. Until the 16th bit is 1, we are checking this condition. So that is that if R5 is not equivalent to this, what is this representing? Repeating once again. Here the R5 is representing 1 followed by 4 zeros is nothing but the R5 initially it is becoming 1, next it will become 2, next it will become 4, next it will become like that until the 15th bit position is 1. We are checking this because we have taken a 16-bit values here. For checking of 16-bit, 45 it is the 16-bit values. Until this position we are checking this thing. So for that case 16th bit, so this is 0 to 15, the 16th bit is 1, we are coming out. So like this loop will be iterated. Here what is the condition we are checking here? BNE, branch if not equal. Which value is not equal? If it is not equal, go back. If it is equal, stop. So what is the value of R5? It is 2. What is that R5 here? 1 followed by 4 zeros. Okay, this is a hexadecimal equivalent value. This is also hexadecimal equivalent value. Now here if it is not equal, go back to which location? Again here. The again has been represented in the red part here. It will come here. So this then automatically comes into the second iteration. Now see here, what is that here? R4 equal to R3 and R5. Here I am showing this one. R3, what is the value? 45. The most significant bits were represented by zeros. The most significant 2 bytes. Okay. Yes, the most significant byte will be represented as zeros. Now what is the R5 value according to this? 2. So 1 0. If you are performing AND operation, here none of the cases it is 1 in the R3 and R5 in 1 it is not there. That's what the R4, the resultant of R4 is zeros. So once it is 0, we are checking that compare R4 comma 0. If it is not equal, increment 1. If it is equal to 0, we are incrementing 0. Okay, so what is the initial value of 0? It is 0. Now it is incremented by 1. There is no jump here. Then after jump, it is skipping to this part. What is this part is? Now R5 will become left shift by 1. What is the left shift by 1? It will become 4. Okay, now once it is left shifted by 1, it is becoming 4. Again it is comparing whether it is reached to the 16th bit position or not. If it is not reached, go back to again. So not equal, jump to again. Again we are coming here. Okay, now we are entering into the third iteration. In the third iteration, R4 equal to R3 and R5. Again, what is the value here? What is the previous value of this? R4 is 4. Now here, what is this value is nothing but, here what is this value here is nothing but 4. Okay, now in the third iteration the value it is, see here, this is 4. Again it is AND operation with 45. What is the resultant of R4? It is becoming 4. Why here the 1 and 1 is ANDed with 1? It is nothing but the resultant is 1. So that case here the R4 value has become 4. So it is not 0 value. So again we are comparing, is R4, compare R4 comma 0. Is R4 is 0? If it is not 0, jump. If it is 0, again increase the zeros. Here it is not 0. Some value it is there. What is this value? 4. So here jump will be there. Again one variable is incremented by 1. Again we are shifting left of R5 by 1. So what is after left shift by 1 time? What is the value of R5 here? 8. So 4 will be multiplied by 2. It will become 8. Okay. So now we are entering into the fourth iteration. In the fourth iteration, again what will happen here? Here the AND of R4 equal to R3 and R5. So what is the R3 value here? Again 45. Here I am showing the iteration here. R3 value it is 45. What is the R5 value? Here it has become 8. That's what it is, 8 here. So here none of the values of R3 and R5 bits are ones here, so the resultant has become 0. Once it is resultant 0, zeros will be incremented by 1. So we will check that one. Is R4 is not equivalent to 0 or not? So we are checking, is if it is not equivalent to 0, no jump. So it is true here. It is not equivalent to 0. It is equivalent to 0. So sorry, it is equivalent to 0. So there is no jump here. The 0 variable is incremented by 1, which is called as 0 is equal to 2. Okay, now once it is there, again it is skipping the branch. It is coming to the branch to the skip label. It is R5 is left shifted by 1 time. So what is the value it will become? The 16-bit value it is 0010. Actually what is it? 0010 is, this is represented here. So this is called as 16. Why? Because this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is the decimal. What is the decimal equivalent value? It is 16. Okay. So is R5 is that is it is reaching to this bit? No. That's what again it is jumping back to again label. Again it is taking R4 equal to R3 and R5. Again we are showing this example 4, 5. R3 equal to 0, 0, 4, 5. And R5 equal to 0, 0, 0. After shifting, the value of R5 will become 16 here. Again it is performing the AND operation. None of the bits are R3 bit and R5 bit are in a one position. So it is the resultant value will become 0 here. Now if it is 0, again what will happen? 0 variable will be incremented by 1. Here it is 2, here it is 3. Again what is that? Again it is coming that it is branch to the skip, branch unconditionally to the variable to the label skip here. So it is skipping here. So again it is coming left shift R5 by 1 time. What is the left shift by R5 1 time? It is becoming 32. Okay, is that it has reached to the end of the position? No. Still how many number of positions are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So still 10 more iterations will be there to reach that R5. Okay, so here what is that? Obviously it has to go back to the this position. So like this, if you are continuing like that, here how many number of zeros and ones are there according to this condition? Zeros are 3 zeros are there. How many number of zeros are there? Here 1, 2, 3 zeros has been counted until this point. And how many number of ones are there? 2 ones. 1, 2. Okay, here you can find out very easily. See here how many number of ones are there? 1, 2. Here 1, 2, 3. So when we reach to the position 0, 1, 2, 3, 4, 5th position we have. 6th position is in one condition. Until this we have 3 zeros and 2 ones will be there. If the iteration is continuing like that, so the value it will become, if you are executing like this, the value will become, see, I think is it visible to you? Okay, is it visible to you? Just check it out. This is the execution of that. After execution we are getting that one. So here here the value of this, it is how many number of ones is that R0 contains 9 zeros, R1 contains 7 ones. Here after executing, see, R0 is 0, 9 zeros are there, R1 contains 7 ones are there. So RT contains that, R2 contains, that is pointing to address of the memory, so it is memory address will be there. DCB stands for define constant byte, so we are taking byte only, so it is occupying the byte in the memory, the DCB stands for. So we will go and just check it out. Here what is the DCB stands for? The DCB stands for here define constant byte. So it occupies only byte data in the memory, and 0xf is nothing but it is occupying also byte in the memory. The align is a assembler directive which is aligning to the 32-bit, okay, but it is showing only byte in the memory. If you are giving here DCH, DCW, DCH is nothing but define constant half word, DCW is nothing but define constant word. Okay, now we'll see here, this is because of this DCB, it is occupying here, yeah, this is that here it is occupying 45 and 0f. Here once it is completed, again the memory R2 will be incremented by 1, it is pointing to the next address byte. Again this process will be iterated how many number of times? 16 times. Okay, hope I understood this concept for you. So this is the each and every iteration, like that how many number of iterations will be going on for 1 byte, it is 8 iterations. Again it is occupying for the next 0f, again 8 iterations will be there. So 16 iterations, that's what it is coming here, 4 zeros and 1s. Okay, so this will be continued and the final resultant value will be R0 contains the resultant. We have to see here, this is in that keil, we are going to execute our program in keil. Already you know that one, we have R0 to R15 registers are there, which is displayed on the left part of that keil processor. R0 which contains that after executing 9 zeros will be there, R1 contains 7 ones will be there, R2 which is the addressing of memory, R3, what is the value of R3 here? R3 contains the content of R2. What is the content of R2? 45. Okay, now again on the next memory location 0f will be there. Okay, so it is there here. Now R5 is that one final iteration, it will become 1 followed by 4 zeros will be there. Okay, so here in the memory, if you are going to that memory will be there here 4f, 45 and 0f. Okay guys, I hope you understood this concept very well. Okay, thank you.